All right. Hey, welcome to Git with T for Team. I was calling this talk like this. I could also say, so it's about Git workflows. I'm talking about Git workflows. But some workflows I want to show today is that's also possible with Subversion. That's just it. So I want you to think about your main project you have at work. So just think about your main project you have at work, not your pet project, just your main project, and think about where do you host your code and which version control system do you host your code, just to get to know you better here. So who's hosting their source code in Subversion? Just, oh, that's still 50% or something. That's okay. Who's using Git? Oh, that's actually a lot. Cool. Great. I love Norway. Okay, somebody uses Mercurial, another distributed version control system like Git. One guy? Okay, good. Anybody of you still using CVS, don't want to move to Subversion because Subversion sucks and just wanted to move to awesome Git right away? Somebody here using CVS? No? Okay. Anything else like Team Foundation Server, Perforce, ClearCase, Visual Source Safe? Okay. Good. Okay. Somebody here in the audience not using any version control system at all? Is there somebody here? No? Thank you. Thank you very much. That's great. Because I think these guys, and I've been using no version control system, I don't know, back in 2000, where I worked with, we were two guys working on the project. It was a pain of keeping track of versions and files, so don't do that. And I think people that are still doing that today, they actually must love pain like the Jackass guys. It's really pain when you don't use a version control system. So I just want to talk a little bit now why Git is good. So why should you use Git? And a lot of people here are using already Git, so this is just a wrap-up. So it's the cheap branching. It's easy with Git to create a branch. It's fast because it's local, so you create branches for releases, for features, for hotfixes. So this is what Git is good at. Actually, this list comes from Lemi Orhan Ergen. I don't know this guy, but it's a pretty good list, pretty cool list, and I think it's pretty complete. Yeah, cheap branching, because everything is local. With Git, everything is local. You can search locally, search the history, find things. You don't have to go to the server. This is awesome. And this makes Git also lightning fast. It's really fast to work with Git compared to Subversion or CVS, if you have worked with that. It's really lightning fast. And then Git is small, and I mean it's designed for that purpose. That you have the whole repository, all branches, all history from the first commit on your machine. It's designed for that. So it's small. It fits on the hard disk. Great. And then it's the staging area, and I think this is the most underestimated feature in Git. Some people turn that off to don't use the staging area, but I think it's great if you're working on a feature, find the bug, and then commit this bug, stage it, and then commit it. That's awesome. That's a good thing. You should use the staging area. And Git is good because of its distributed nature. So Git doesn't require to have a central server. You can work without a central server. You can work in a distributed environment. So sending around patches, sending around pull requests just between two repositories, local repositories, that's all possible. And Git is good because of the awesome tooling like GitHub and Bitbucket. In the original list, I must say, from Leni, there was just GitHub saying GitHub, but of course, because Bitbucket is as awesome as GitHub, so I had to add this. It's an Atlassian tool, so. And actually, Git is the new standard. And you will see more and more features coming up from tool vendors that support more Git. I mean, I don't say that Subversion will go away or Subversion support in tools will go away. We still have it like we have now CVS support in tools. But we will see more and more features are developed directly for Git. So it's actually the new standard. Yeah. And Git is great because of the huge community. There's a huge community behind Git. If you have a question, a very passionate community sometimes if you ask what is better, merge or rebase, but very passionate, but you get an answer for everything. That's pretty cool. So all these things I will not talk about today. This is what I not will talk about. I will talk about the awesome workflow capabilities you get with Git. This is what I would talk about. And you will not get this detailed view like you're driving on a road and then you're turning right to the next motorway or whatever. Like your navigation system is telling you, please turn right now, and you don't care about, yeah, I turn right, and you don't care about why you turn right. Your navigation system takes totally control of that. You don't have to care about that. And I don't want to talk about this, what commands you should use in Git for merging or for branching and all this. I won't talk about this. I will instead of this, I will give you a little bit more of a bird's view. So if you talk about the navigation system, it's more the map. You look at the map and see where you navigate through all the workflows, through your code, where your code comes together as a team. So I will give you an overview over your workflow. This is what I would do. So Git is actually designed for open source. So Linus Torvald, he invented Git. Because he wanted to, he said Subversion sucks, so I need a version control system that's way better, and I need something that works for my Linux kernel, for developing the Linux kernel, to get the community involved, to apply patches to the Linux kernel that people can work offline also, so all over the world can work offline and apply patches to the Linux kernel. And then he's sitting there cherry picking the features he want to have. This is a totally open source process. It's a distributed workflow. So I can easily work together with a colleague he's sitting in Brazil somewhere without internet connections, and when he gets and we work together, and when he gets internet connection again at an internet cafe, he can send me the patch and I can put it into my version control and my Git repository. So it's a totally distributed workflow, and this is great for that. But actually, we all work in companies. We go to an office. Normally, we go to an office building, and we have a centralized workflow. We need a place where the code comes together, a central place where all the code comes together. And companies like that, to work like this, that there's one place where actually the actual software lays. There's one place for that. And yeah, this is a little bit, yeah. So we have this distributed thing, and then we want to have a centralized place. And I explained to you how you could use Git for doing the centralized. And I'm sure you're doing that already for the centralized workflows that companies require. And I care about workflows. So I'm Sven. I'm working as an ambassador for Atlassian, and I've been working before as team lead, as developer. So I have a lot of experience with developing code. And I actually, as a team lead, I cared about workflows. I introduced continuous integration that we know that we can deploy the software. I introduced code reviews, so a process for code reviews. And I wanted to make, and I still want to make the developers more productive. And they shouldn't care about so much things. They shouldn't think about so much things. The workflow should just be clear, and everybody should know what the workflow is. And I've been in a lot of companies, talking to a lot of people, and I see this pattern here a lot, where there's normally one or two guys who knows how the workflows are, how things are working. So it's actually the questions, can we fix that for the upcoming release? How does that work? How do we get the code in the upcoming release? Can I just put it into the trunk or into the master branch? How does that work? Or is the code already feature complete? Has everybody committed everything that we can now go to the next step, to quality assurance or whatever the next step in your company? Is it now complete? Has everybody committed their features? Then it's, can we do actually a hotfix for the current version? how does that work? And I've been to companies where there's normally one guy, he's the god of the repository, and I say, okay, here, this is my change. Please make a hotfix for the current version with that change and do it. So he's taking care of all this stuff. Or can we build the current code? Is it buildable? Is it build red? Can we see that somehow? Are we aware of that? Or has everybody actually reviewed the code? Is it quality assured from our side that we say, hey, it's great code, we can now give it to QA, or we can deploy it directly to our production or test servers? All this question around workflows, and it's not clear in some companies, in some teams, it's not clear what to do with these things. And Darth Vader would say, I find your lack of workflow structure disturbing. Because really, and it is disturbing, we should know what's going on. We should really know what's going on with our workflow. We should know how to do a hotfix, or if all features are complete, checked in, and we can deploy it now. So, but say that is, so we have different people in the team. There are some people in the team that needs really structure. They need really structure, and then some people, they need freedom. They might need more freedom. And teams are also different, so different people needs different workflows, and also different products. If you're doing a nuclear power plant software that you release once a year, you want to be sure that this thing is working. So you need a different workflow than somebody who's doing a web shot for web napkins or something, and the service is down for half an hour. You don't care. So different products need different workflows. So for example, we're doing Jira, Bitbucket, and Stash, and these are different tools, different products. Jira, for example, has a release cycle from maybe 3 to 4 times a year. So they have another workflow than the Bitbucket team, who just releases whenever a feature is ready. They just release in the cloud. It's a cloud service. Jira is a download software. And then we have the Stash team. It's a pretty new product from Atlassian, Git Repository Manager. And the Stash team has a 6-week release cycle. So also, they have a totally different workflow compared to the Jira team. So this is different products need different workflows. And then you have different cultures. So also different cultures. If you have a culture that you're afraid of failure, for example. I don't want to value that right now, but some cultures are that way. Or you have a culture where it's okay. If it's a failure, we fix it. Hey, who cares? We learn from that. So, and different cultures needs also different workflows. So all of this needs different workflows. So, but what does Git give us? Yeah, we can build our own workflow. So Git gives us just this Lego briquettes, I would call it that, like that, where we say, okay, it's a fork, push, rebase, clone, merge, pull, whatever there is, fetch. And it gives us just the briquettes, so like commands, and we can build out of it whatever workflow we want. So we could easily build a rocket ship out of it. So something like a very fast workflow that's very flexible, and can react very fast. Or if it's required, we can also build our very stable workflow. Maybe we release just every second month or something, or once a year. Very stable workflow, very structured. So whatever workflow you decide to do, or are you required to do, Git can do that for you. So, but said that there is one workflow that is not possible with Git. And it's possible, but I will come to that later. Everything is possible with Git, but it's not out of the box, not possible with Git. And there's also this workflow really doesn't work. And it's blocking files while working on it. I actually met a guy a few months ago. He said, I will not move to Git until this is done in Git. And I said, you will never get it. So I worked for a company. I started actually in 1999, and we had that files were blocked on the server, so I couldn't change it. I just could check it out, but I couldn't change anything. And we had to apply a fix. And yeah, we all know what happens if we go down that lane. So yeah, so this is not possible with Git is it's a very, very team-oriented workflow, so everybody can work on the files. Okay, let's start with some workflows. And I will start with fork workflows. Who has done a fork here in that room already? Yeah, that's half of you. Cool. So let me just explain what a fork is in Git. So a fork makes actually a copy on the server of your total repository with all branches or history, makes a copy of that. And a fork is you cannot write directly to the repository anymore, to the original repository. You have your forked repository. You cannot write directly to the original repository. But what you can still get changes from the original repository into your fork. So you can still pull in changes from that. So what can we do with that? Let's have a look at the first workflow that we can do with that. And that's the so-called gatekeeper workflow. So let's assume we have this awesome library. We want that, but it's not like we have to change things. So it's an open source library, but we have to change things to make it work for our product. So we're doing a fork. So we're making a copy of it on the server, and then we have a forked repository. The good thing is you still get updates. So if they find a bug in the repository or in the software, you still get updates from the original repository. You get them normally manually, but there are also tools like Stash, or you can write some Git hooks where you can get automatically the updates merged into your repository. Okay. So let's assume you have done some awesome changes. And now you think, well, maybe we can contribute that back to the original repository, so everybody that uses this software can have this thing. So I already said pushing back is not possible. That's not possible. We cannot push back. But we can ask the so-called gatekeeper. He's sitting there, and you can ask, send over the diff and say, oh, we fixed that, or we added this thing. Do you want to have that in your original library? So I think it values, everybody can use that. It's a great thing. So yeah, and he likes the changes, so he pulls in the changes and updates his repository. So this is in short terms the gatekeeper workflow. That looks a little bit like an open source process, doesn't it? I mean, really, yeah, and it's great. Exactly, it works great. So we should learn more from open source teams. So why can we not learn from open source teams? It's not a bad thing. We have distributed teams and open source teams, and that's what we see more and more coming in our companies. People work from home, people work from anywhere in the world, and that's working with open source software development, and we can get that for companies too. Then we see that people have different programming skills in open source projects. So we are sure we don't pull in software that is not really good. So they have different programming skills there. But we also have that in companies. We have interns that are working on the code base, and we want to be sure that the code is good that we pull in our code base. So we can learn from that. And then they have flexible roadmaps, open source teams. So and we want that in companies desperately. We need more flexible roadmaps. So where can I actually use forking in the enterprise? So in bigger companies, where can I use that? And I give you 5 reasons for forking in the enterprise. So reason number 1, I already said that it's great for customizing libraries. So if you find an awesome library, you have to customize that. That's where forking works great. You still get bug fixes, as I said. Reason number 2, and we use it at Atlassian for our Ship It days. It's great for innovation spikes. So we're doing every quarter 24-hour hackathons where we just try our innovation idea, try to put it in the software. So we're forking Jira and just hack the hell out of it in our forked repository. And maybe later, if we think this is good code, normally it isn't, but maybe later we can add this back still to the original repository if we think this innovation idea should go into the original original software. So this is where we use it for. Always throw it away. So you could use it easily for prototyping. Just use a fork. Fork this. You have the whole history, everything, and you can get wild with it. So reason number 3 is protecting your components. At Atlassian, we have a group called the Atlassian User Interface Group. And they are actually developing a library for all Atlassian products, the user interface library. And people cannot change the code directly. They have to do a fork. So the Jira team have to do a fork of the Atlassian user interface library and then change things and then ask this team that takes care that everything is fine with the library and it works also with Confluence and with Dash and with Jira and all these things and then pull in the changes. Reason number 3, it reduces noise. So if you're using forks and work with a team on the fork and then have a big pull into the original repository, it reduces noise in the original repository. So you don't have that much noise in there. So that's great for huge projects. You can keep an overview over huge projects. And if you interact with contractors or interns, forking is also great. So you give your contractor just a forked repository. They can totally work on that. And then you pull in the changes. You can quality assure then. You don't need a VPN tunnel to your repository. They can work independently on their forked repository. That's working great. Forking works great in the enterprise for that reason. So let's have a look at another workflow. This is called the dictators and lieutenants workflow. This is a little bit like the like the gatekeeper workflow, but just for huge projects. So it's working like this. You have an army of developers. So really a lot of developers that are working for you, and then you have this few integrators, this few DAS waiters that integrates the code. Maybe you put it in okay, this is a user interface integrator, this is the export integrator, whatever you want. You can do things like that. And then you have this friendly dictator. I'm from Germany, so I have to say that. It's a friendly dictator that pulls on the changes from the integrators. So this is the gatekeeper and lieutenant workflow. Let's have a look at it a little bit closer. So everybody is syncing, of course, from the so-called blessed repository, so from the big repository that the gatekeeper is sitting on. So everybody is getting their syncing their repository with that. And then you have they want to pull in the changes, but the gatekeeper says, oh no, that's too much stuff, too much developers, too much stuff. So we have actually these lieutenants that take care of that. That it's not too much for the gatekeeper. So we slice and dice here. So actually the lieutenants are here to help, and that works great for huge projects. If you have a huge project, that's a great workflow. Yeah, but you also maybe you also get a potential bottleneck by doing that. I mean, if I want to apply a patch to the software and that this has to go out very, very fast, I have to wait for the lieutenant that is sitting maybe in another time zone, then wait for the gatekeeper that is sitting in another time zone. So it's nothing for very, very fast development. Or you can maybe work around that if you want, but out of the box, it's nothing for fast development. So this is a potential bottleneck you have with this workflow. If you actually need more freedom and you want to move faster, there's another workflow for you. I want to show you. So we're going away from forking now. And this is the centralized workflow. And I know there was a lot of hands up for Subversion and Hello Subversion users and former Subversion users. This is exactly your flow. This is your flow. But Git makes it even better that way. So you have actually this master branch, or as you formerly known as trunk. And all codes goes in here. So all teams work on that one. All people work on that trunk. All code goes in here. So what you do with Git is you have your central repository, you make a clone of it. So this is not a server-side copy, it's a local copy on your local machine. And then instead of of what you can do with a fork. You can pull and push, force them back with that. So that's possible. So you have your full local copy on your cloned repository. And everybody integrates the changes just on the original repository, on the central repository, and working on this one branch. And please, please, please do that very often. Martin Fowler from ThoughtWorks said you should do that once a day, maybe, to call it continuous integration. But I would recommend you do it more often, 5, 6, 7 times a day. Get changes from the master branch on the central repository and push your changes upwards. So, what is that workflow good for? Well, you get it. It's very simple and easy to learn, and everybody will understand that. You integrate your code on the same code base. Very, very simple, very clean. Conflicts gets visible early. If you get a conflict with a colleague that changed something, well, this gets visible very, very early in the states. You try to push up your code. You see there's a conflict. You have to resolve that. So very, very early. If I said 5 times a day, you get 5 times a day. You can see you're checking if you have conflicts. If you add continuous integration, and I recommend that, the master branch should always be deployable if the build is green. Please ensure that the build is green on the master branch. And it has been used for years and years and years, so we know it's working. It's nothing that's not working. It's really working. A lot of teams using exactly that workflow, and it's working for a lot of software companies. So, and another thing is, it's great for migrating. So you don't, if you're using this ogre Subversion and you want to move to a unicorn riding on rainbow Git, then this workflow is really great. And we used that at Atlassian when we migrated 2 or 1.5 years ago to distributed version control systems. We changed. It's enough that you change the version control system, have them all. Everybody has to learn the new commands, and everybody has to learn that they commit now first locally, and then they push their changes up. So this is change enough. So don't change your workflow. Recommendation: if you move to Git, don't change your workflow and keep your centralized workflow. But there's also one issue with that, and this is that you get unfinished features in your master branch. There will be unfinished features. You push 5 times a day. Your feature won't be ready maybe in one commit. So you will get unfinished features in the master branch. This is the downside of it. What you could do is, and what people are recommending, use feature toggles. So if you have a button that is not doing anything because you haven't coded the logic behind it, use feature toggles, turn off that button that's not visible. So this is how to code with that. But maybe there's a smarter way when you're using Git with it. And this is the so-called feature branch workflow. So if you think about how we organize our work, we organize our work in tasks, in user stories, in features. This is how we think. We want to solve this thing. We want to solve this add user thing, that somebody can add a user. This is what we have in mind. And then we have our commits that we may tie to it. So we have 5 commits that really solve this problem. But why? And then we can tie it together at the end, see, okay, these 5 commits, so this code changes relates to this feature. But why not have it directly in code? Why can we not have it directly in code? So you can use something like branch per feature. So you branch per feature, and then you can have 1 to X developers working on that feature branch together. I see mostly that just 1 developer working on 1 feature branch, but you can work with more people on the feature branch, no matter. So what you do is you develop on the feature branch, very isolated, and at the end, you merge your changes back. And important thing, close the feature branch when it's done. So this is actually the feature branch workflow. And the advantage is you get a very, very clean master branch. The master branch is very clean. You know there's not unfinished features in the master branch. You should deploy it directly. It's feature complete, so you know when features complete is. So it's a very, very clean and stable master branch. You get a much more stable master branch than with a centralized workflow. And you can work independently on your features. very independent work on your own features. You don't get disturbed by changes from other developers with their half-baked features into your changes. So it's a very, very isolated, you get an isolated feature development. What is it good for? It's great for fixed time projects. If we say we have to release on Wednesday, so we take everything that's now on the master branch and release it. Because we know the features are complete that are on the master branch. There's not missing a commit like in the centralized workflow. We know it's complete. So, and then for fixed feature development, it's also good if the last feature has been checked in, we can go with our development, with our release, sorry. And we can still develop while we bug fix this one. So this is also cool. So we can still work on other feature branches while we bug fix the release. And it's great for continuous delivery. You can deliver the code when it's actually done. So you have a feature ready, you push it out. You have a feature ready, you push it out. So you can, it's great for continuous delivery, push it out to your test server, to your production server, whatever your workflow is. And here are actually some feature branch tips, how you should use feature branches, merge frequently. This is actually advices from Atlassians. I asked some Atlassians, so what are your recommendations for the Norwegian developers in Oslo at JavaZone? And they say, merge frequently, have small features so for example, we use feature branches that exist maybe two days, and then we merge back. So we have very, very small, maybe that's also just tasks, but very, very small, short-running branches. If you have longer running branches, sync frequently with the master. So sync your feature branch frequently with the master, get the changes from the master, and you know that the features are complete that you get from the master because you just merge with the master when your feature is complete. So if somebody completes their features, it gets in the master branch, you know this is now feature complete, so it's not a half-baked feature that you get into your feature branch. And then, very, very important, delete the feature branch when it's done. We had something like, oh, I thought I fixed that, and I fixed that bug. So on the feature branch, and it was fixed on the feature branch, but he forget to merge it back in the master branch. So if you're done with your feature, you think you're done with your feature, delete it, delete your feature branch. If you find a bug, make a new feature branch actually. All right, branch per feature. Another advice: use useful branch names that you can identify the branches. So something like add user or delete user, something like that. Because if somebody gets sick and this important feature has to go out, you can just look it up, see the feature, how far he has developed it, and finish it. And if you got an issue tracker, you should also enter the issue number there, that you know which issue description goes with this feature branch. That are our recommendations. All right, let's make the feature branch even awesomer, more awesome. And then that's where we have the feature branch and we add some code reviews to it. So why actually should we have code reviews? Why should we discuss changes with each other? Let's ask our game show candidates here. Hey, Andy, Julie, Steve, and Lynn. This is your million-dollar questions. Why do you want to discuss your code changes? Okay, let's have a look. Lynn is pressing the button and says, yeah, she want to learn. And that's the best answer you can give. You want to learn from each other. You want to see what's going on in the code base, so you learn something. If the importer class changes or the importer library changes, you see that. You have no idea what this is doing, but you can see the changes. You learn from it. And we learn from other developers how they solve problems. So this is the best answer you can get. Somebody else want to press the button? Oh yeah, Julie. Better quality, sure. We can discuss the changes. We can say, oh, there's a magic number. Please use a constant for that. So we get better code quality. Good. Somebody else pressing? Andy. I want to feel better. I feel better if somebody looked at my code changes and say, yeah, good. Good. So you don't have the pressure just laying on your shoulder that this feature works. Somebody else has looked at the code and say, yeah, it's okay. So this is great. I'm feeling better if somebody really reviewed my changes and said, I approve that. That's good. Steve, you're the last one. Please press. What's your answer? I want to blame people. Wrong answer. That's not what code reviews are about. We should have a friendly discussion. Really, that's very important. Not to blame people. We shouldn't do that. That's not good. Okay, how do we do that in Git? How do we discuss code changes? Through pull requests, so-called pull requests. So what's a pull request? So you're doing your feature branching. You want to merge, but you don't merge. You ask your teammates, hey, what do you think about the changes? And then you can, there are actually tools out there like GitHub, Bitbucket, Stash, Garrett, Gitorious, you name it, that actually are giving you a visual interface so you can discuss the changes. You can click on the code line, add a comment, and discuss the changes. And then after the discussion and you're ready, all changes are good now, then you say, good, agree, and approve the pull request. And then you're actually allowed to merge the code back into your master branch. Cool, great. That's very good. And this is actually what GitHub uses, actually what I get from the Tech Holman's talks, how GitHub works. Are GitHubers here in the room? Somewhere? Yeah? Can you agree or slightly different? Okay, cool, thanks. So this is the GitHub workflow. Okay, let's add some history to this feature branch workflow. We actually shouldn't forget about our past. Yeah, we all have a past. That's true. So we shouldn't forget about it. So I introduced now another branch, and this branch is called the develop branch. Actually, what you formerly known as master branch is now the develop branch. So we actually work on that, make feature branches. We change things on the develop branch. And then if we are ready, if we think now we can deploy our changes, we merge our changes to the master branch. And that makes the master branch really, really stable. This is just the version that's out there. That's on the master branch. If I want to debug things on the master branch, I just on the production servers, I just can take the master branch and debug on that. That's cool. So this makes the master branch very, very stable. So this is actually what the Bitbucket team does at Atlassian. So this is the Bitbucket workflow, what the Bitbucket team is doing. They actually they call this branches differently. They call this staging and production because it makes more sense for them to call it that way. So in staging, it's always the upcoming version, and of course they also only do merges through pull request, except when they're not doing it. And then they never integrate here. They never integrate directly here, just for hot fixes, and I come to that later. They're doing that. And then, without a pull request, of course, they merge back to the... Sorry, without a pull request, they merge back to the production branch. They're doing that. So this is the Bitbucket workflow, how the Bitbucket teams works at Atlassian. Okay, let's have a look at the release workflow. This is all cool stuff. People are just flowing. Hey, we got a feature ready. We push it out. Isn't that cool? That's awesome. We are flowing all the time. Wow, cool. But some of us, we need we need to inspect what we want to release. So we actually need something like a release candidate. But we don't want to destroy the flow of the team. That's what we don't want to do. We still want the team keep flowing, but we want to be sure that we release awesome software. So how does that release workflow look like? Yeah, we're making a branch from the develop branch. We're making a release candidate branch. So if we say this is now feature complete, we're making this branch, and then we actually the release team or whatever people you pick works on that branch. They're fixing bugs. They're inspecting that branch. QA can work on that branch. And then the other dev team that is producing features for the next upcoming version, they can flow on the develop branch. So they make in their feature branches, they are merge, great. And then if the release team finds a bug, they merge frequently, of course, into the develop branch. And once they're ready, they think, this is now the version we want to release. Awesome, great. They release it, so they merge it to the master branch and to the develop branch, and then delete the release candidate again. So this is how you do releases. So what is it good for? Well, if you have a promised set of features, I already said that, it's a very, very good thing to do. And you want to be sure that the features are good quality, then that's a good thing. Maybe if bugs at your company have a big impact. So if you find a bug and it stops the service and you lose a lot of money, or 1,000 people cannot work because of the bug, maybe you want to be sure you nail the release. If your releases are expensive in your organization, so if you have to have a server downtime and then people cannot work for half an hour, then you want to nail this release. Or if you have a culture that is afraid of failures, you also want to be sure that the release is really good. So that's when you use the release workflow. Okay, the maintenance workflow. So, you know what? I mean, you're doing software every day, and your software has bugs. Sure, they have. And you push out your changes and say, oh, I hope the telephone is not ringing. But sometimes somebody calls you up and says, I cannot export the PDF anymore. Say, oh, shit, I have to look at it. So what are you doing? What are you doing in your workflow? So you take the master branch, the version you just tagged, and make a hotfix. So you merge your branch from the master branch, make a hotfix, and fix the damn bug. At the end, you merge the master branch, tag it, release it, and delete the hotfix branch again. Of course, don't forget to also merge it back into develop. That's the maintenance workflow. There's just one exception with the maintenance workflow, one exception, and that's if you have a release candidate out there, you don't merge back to develop, you merge back to the release candidate. This is what you're doing. And then, of course, delete the hotfix branch. This is the one exception. All right, let's have a look at the next workflow, and they call it the Git flow. Ooh. So here's the Git flow. You've just seen it. That's Git flow. That's what they call Git flow. Actually, it's Vincent Grison who made this, who came up with this flow, which is pretty awesome. So what's the Git flow? Just to sum that up. So we have a develop and a master branch. We have feature branches. We have release branches. And we have maintenance branches or hotfix branches. And you set the naming, and that's also very important. You set the naming. How does a feature branch called that you can distinguish in your repository? What's that branch? Is it a feature branch? Is it a hotfix? A release branch? Very important that you have a consistent naming in that. But there are so many rules. I mean, remember that rule that if you're doing a hotfix, you're not allowed to merge to the develop branch because you have to merge back to the release candidate branch. So if you have a release candidate out there, so there's so many rules, and I mean, I'm not doing a hotfix maybe every day, and I have to remember that, or I have to look it up how it works. Well, there are some awesome tools out there that actually can help you with that. And actually, Vincent Grison, he wrote a tool himself, a command line tool, where you just say git flow feature start, and it makes automatically a branch, switches to that branch, and you can work on it. Or you say hotfix finish, and it merges to the master branch, tags that master branch, merges to the develop branch automatically, so you don't have to care about that. That's what I said is your navigation system. There's also some visual tools out there like Atlassian Source Tree that is doing git flow, so it's a more visual thing where you can just start a feature, press on start feature, and then merge this feature, so finish this feature or release this version, this release candidate. That's also possible. So now you might ask me, hey, didn't that guy just said at the beginning, there's just no one flow that routes them all? I thought every team is different, every product is different, every culture is different, so that's stupid to do the Git flow. But I must say to that, well, it captures actually a lot of development situations that we have. I mean, I've been working with a lot of teams, and every time we're doing a release candidate, yeah, we're doing that. We may have to do hot fixes on the actual version, all the stuff we have to do. So it captures a lot of situations that we have in development. And it's well known, so a lot of people know that Git flow, so you have an easy adoption. If you get new employees into your company, that's they know what's going on. If you say, we're using Git flow here. But I won't use it out of the box. So you have to adapt it. And that's also what we're doing at Atlassian. So here's actually how the stash team flows at Atlassian. So it's not the stash flow, it's the stash team flow. This is how we do development with stash. We wanted to make Git flow more simple. And we said, we want to get rid of the master branch. That makes it more simple. But the stable branch is gone. Oh my God. Yeah, but we said, we're keeping the release branches. These are our stable branches for the different releases. So we don't have a master branch anymore. We just have develop branches. This is how we work, how we release. We're taking the release, and then we keep the release branch. So we merge back to develop and release it from the release branch. If we're doing a hotfix, well, that's also very easy. We're doing a hotfix from the release branch and merge it back to the release branch. And then from that, we merge back to the develop branch. What makes it much, much more simple. It's more simple and it's more clear, more clean, because you don't merge into two different branches. You just merge to release and from release into develop. It's much cleaner. And then we have this problem, or this situation at Atlassian, that we have to support older versions. We say we support versions from 2 years ago. And we know old software has bugs, and somebody comes up and say, oh, I have a problem in version 1.5. And so 1.5, what's that? So how do we fix bugs here? So this is also what the stash team has to do, has to code with. So we have this version, and we want to fix the old version, the 2.0 version here. And we're doing a hotfix like we did before. And then, actually, we merge back into the release 2.1 branch, if we want to fix that bug also there. And then merge back to the develop branch. Also here, very, very clean, very clear. We merge just to the different states of release branches. But said that is the stash team flow that can change tomorrow. I mean, I talked to the stash team 1 month ago, and they said this is how we flow, but they probably have changed things right now. So it changes, and this is a good thing. So another thing that the stash team is using, they have robots, and these robots want to help them a little bit. So let's have a look at that, where we use robots in the stash team. Actually, if we fix the hotfix, if we merge it back to the release branch, there's this robot that says, I could do that. And so we're doing, it merges automatically with the develop branch, which is pretty cool. So these are server-side auto mergers. And at the end of the slides, I have links to the source code, so you can download the source code and do that also for your repository. And we realized that with Git hooks. This is how we do it. Pretty awesome stuff. But now, lean back and enjoy pure awesomeness. Have your attention now? Great. So, if we do a hotfix on an old version, well, there's this robots coming in and merging us all the way back to the develop branch, which is totally awesome. We don't have to care about that, except when we don't have to fix the bug, of course, in the version 2.1. Then we don't want to have the robots doing that. But normally, we actually merge it back and automatically runs on this release branch and deploys automatically the version. So this is how we work. Does that give you enough possibilities? No? Not enough possibilities? I will give you infinitive workflow possibilities. Because actually, you can customize every workflow you have with hooks, with Git hooks. You can write Git hooks. So Git hook, every command that you're doing with Git, you can add a Git hook to it. So if I push changes, for example, I can hook into that process, let a script run, and then execute the push afterwards. Or I execute the push and then let my script run. So we're using hooks at Atlassian, and I have 2 examples here where we use hooks. This is hook magic at Atlassian. So the first hook I want to show you is don't branch from a red build. So I've done that a few times where I just make a branch from the master branch, just fix 2 lines of code, merge it back, boom, the build failed. I have a red build. And I was thinking, can't be. I just changed these 2 lines that cannot break this test. So after 1 hour, I found out, oh, the build was already red when I merged, when I branched. So we have a hook that is just allowing us to branch from a green build. So we can just make a branch if the build is green. So there's a continuous integration server talking to that hook. And if I merge, if I branch, it's checking if the build is green currently on the develop branch. Pretty awesome. Then we want to be informed about everything, and at Atlassian we're using chat for everything, for discussing. Also, our Git repository is talking to us through chat, and we are also using hooks for that. So we hook in different Git commands in our Git repositories, and then we know what's going on in the code base, we know what's coming, and we're actually having also our continuous integration server that's telling us the build is green or the build is red. We have to do something. Talking about continuous integration, let's have a look how workflow works with CI servers. Now, we want to add now a continuous integration server. So what do we want to reach with that? Well, we want to have a stable develop branch. It should be always stable. So people are branching from that one. So and we want to deploy maybe automatically from that one. So this branch should be totally stable. And we don't want to introduce a red build on that one and let people down and they cannot branch anymore from that branch. So we want to be sure that we don't break things. So what we could do is now 2 things. One thing that I did a lot in the past is we pull in the changes from the master or from the develop. Then we build it locally, and if the build is green, we know everything is fine. Then I can merge back, and it will hopefully be also okay on the develop branch. What we also could do is, and what I also did a lot of times in the past, we could just merge and pray, hope that the build stays green. That's maybe not the best thing to do. So why can we not use auto merges on feature branches and build it from there? So we merge automatically the changes into our feature branches and build it from there. Make an automatic build there. So let's have a look at how this looks like. So we have a potential integration problem here. You can see that I branched and then somebody other merged a change in there. So there's a potential integration point. So we can actually pull in frequently. I told you that, and we can actually automatically pull in frequently on commits. So we can auto merge on our feature branch. But this is pretty awesome. So I run a build on my feature branch, and I know, okay, everything is good with that new feature. But sometimes things just happen, and somebody adds crappy code that's destroying the build on the develop branch, and then all of a sudden I have this crappy code also in my feature branch. So here are continuous integration servers. Great. You can push automatically just on green builds. So just if the build is green, you push the code automatically to your feature branch, and this is continuous integration actually. So you might say now, oh, this poor continuous integration administrator that has to make a new settings for each feature branch to let the build run on this feature branch. Well, yeah, he has to set up all the builds. But there are also some continuous integration tools out there that actually have a feature like auto-detect feature branches. So they automatically detect there's a new branch, so I build that automatically, this branch. So this is pretty awesome. I know that TeamCity and Bamboo is capable of doing that. Does anybody know if Jenkins can also do that? So yes? Okay. And I will update the slides. So yeah, so use that. that's pretty awesome. You make the life of your continuous integration administrator much, much better. What we learned at Atlassian, build on every commit that really, on our feature branches, killed our CI service. So we are not doing that. We're not doing that. So that really was server overload. What we do is we build manually. That's a trade-off. Yeah, it would be great if we could build automatically, but it wasn't working in our environment. So here's what we do. We build on every commit, of course, on master, on release, on develop branch. So we know that's OK. We build manually on our feature branches. The build setup is already there in our build tool. We just have to let it run. And then we're doing auto merges on green builds on develop. So we merge automatically new features into our feature branches. OK, 5 minutes left for issue tracking. That's where we are experts at Atlassian with issue tracking. So different people actually have different views on projects. So we have different people that's working on the project. So we have the cool developers. Then we have the amazing Scrum Masters and the incredible product owners. And they all have different views on our project, on our code base, on our features. And issue trackers, actually, they connect us coders with the real world. I mean, the real world problems are captured in the issue tracker, and we want to live in code. We are coders. We want to live in code. Actually, issue trackers connects Git with the real world. This is what issue trackers can do, because the real world lives in your issue tracker. So as a coder, I want to live in code. I don't want to actually have another application that I have to start or whatever. So let me work in code. I just need to know what my code should solve. That's what I just read. So I go to my issue tracker, whatever issue tracker you have, Bugzilla, Mantis, Jira, GitHub issue tracker, Bitbucket issue tracker, whatever. You go into that one, look at what issues you have to solve with that, and then you go over to Git repository, to your code, to your IDE, and fix the bug, or write the feature. Then you have the other side, the product owners that sees in the issue tracker, oh, great, the guys have started now with coding. So actually, and then you commit with commit meshes. You can control your issue tracker. You can do that with a lot of tools, as I said, with GitHub, with Bitbucket, with Jira. And then you control that this issue is now fixed, so it's automatically set to fixed, or whatever workflow state you have there. So you control that. You don't have to go into your issue tracker. You can control that from the commit message, which is pretty awesome. So what's in it for non-geeks? Well, they can see immediately what's in develop, what's in review, and see finished issue when they are already merged with develop. So that's what they can see. What's in it for us coders? Well, if we're doing, for example, pull request, code reviews with pull request, and so Stash is, for example, capable of doing that, showing the issue tickets that leads to that software changes, to that code changes. And that's pretty important. If I want to review changes, I want to know what does that code solve. So I can see that directly next to the code, which is pretty awesome. And then, of course, if I use an issue tracker, I can browse the description and then find the code that has changed. But actually, I think this is not enough, actually. So I actually have a dream. We're not there yet, but I'm working for Atlassian, so I'm pushing the development team to implement that. And so let's have a look at our Git workflow. We're doing a feature branch, we're doing a pull request, and at the end, we merge the code back. Let's have a look at the issue workflow. That looks a little bit different. We start progress, the issue is in review, and at the end, it's resolved. The issue is resolved when I'm done. So how do I bring these things together? And I have a dream that in the near future, maybe all tools can handle that. If I start progress on an issue, it creates automatically a feature branch for me, switches to that feature branch. I go into code, write my code, doing a pull request. It sets automatically the code in review. And then if I merge, the issue tracker is that smart that it sees, okay, now the feature branch is deleted, it's merged, so the feature is resolved. This is my dream. And we see that now that we have more and more features coming up like this with the rise of the machines, of the Git tools. So we will see a rise of the Git tools where we see what's all possible with Git, with the new technology. And please be sure that we will not see a rise of the Subversion tools. We will see a rise of the Git tools because this is actually what we see also at Atlassian as the future. I want you really to think about your workflow. What is your workflow in your team? What is the best workflow for your product? And please, please, please don't flow like it's 1999. These times are hopefully over. We can do better than that. So thank you very much. Thanks for your attention. I see I'm just over the hour here, so I won't answer questions now. Atlassian has a booth out there, so I'm staying here. I will be here right now after this talk, and that's a lame thing. Tomorrow I'm doing a quick talk, 10-minute talk about why you shouldn't use Git, so totally the opposite. So come to that talk tomorrow at 3 p.m. in room 7. Thanks.